Good morning, my dear students. Yesterday we started a very important topic called quantum numbers. We finished two quantum numbers, namely principal quantum number and the angular momentum quantum number. This indicates the main energy level in which electron is present, and L indicates the sub-energy level in which the electron is present. Today we are going to take up the other two quantum numbers. So the next quantum number, the third quantum number, is magnetic quantum number. So magnetic quantum number is represented by the letter M. The value of M is from minus L to plus L. We know what is L. L is the angular momentum quantum number. Based on that only, magnetic quantum number is depending on. M is indicating the orientation of electron. So when we say orientation, it indicates the direction of the directional movement of the electron, right? And this mostly gives the explanation for Zeeman effect. The splitting of the spectral line is due to the movement of electrons in different direction in the presence of the magnetic field, right? So in turn, we can also say that the different orientation in which the electron is moving, in other words, is being called as orbital. Therefore, in short, magnetic quantum number is one which indicates the orbital. For example, suppose if we take S subshell, right? What is the value of L? L is 0. Therefore, M will have a value from minus 0 to plus 0. Therefore, there is only one orientation for this, right? Whereas if you take P subshell, so it has got only one orbital, right? If you take P subshell, L value is equal to 1, M value will be from minus 1 to plus 1. So what does it mean? M is equal to minus 1, M is equal to 0, and M is equal to plus 1. Therefore, it has got three directions in which electron makes movement. Those two orientations are called as three orbitals. That means this P or P subshell will have Px, Py, Pz. So these are the orientations that are being called as orbitals. If we go to D subshell, L is equal to 2. So M value will go from minus 2 to plus 2. Right? That means it will have minus 2, minus 1, 0, plus 1, plus 2. Therefore, it has got how many orbitals? 5 orbitals. D subshell will have 5 orbitals. Suppose if you go to F subshell, L is equal to 3. Therefore, M value for this will be from minus 3, minus 2, minus 1, 0, plus 1, plus 2, plus 3. So it has got how many orbitals? 7 orbitals. It has got 7 different type of orientation of the electrons. So that is about the magnetic quantum number. So magnetic quantum number fixes the orientation of the electrons, and it is being called as the orbital, and its value is always depending upon L value. That it goes from minus L to plus L. So this is about magnetic quantum number. Then finally we have spin quantum number. The last quantum number is spin quantum number. So when it says spin quantum number, it is obvious. Electrons are revolving around the nucleus. So it is not only revolving around the nucleus, it will be almost spinning about its own axis. So electrons will spin about its own axis. And the spin can be only two types of spin. One is clockwise spin, the other one is anti-clockwise spin. Right? And it is denoted as S. And S can have only two values, either plus of or minus of. Plus of will indicate clockwise spin and minus of will indicate the anti-clockwise spin. So this is about the spin quantum number. Therefore, if you want to study the characteristic of an electron, you have to have how many quantum numbers? 4 quantum numbers. First, the principal quantum number will give the main energy level, and then the angular momentum quantum number will give the sub-energy level in which that electron is present, and the magnetic quantum number will indicate in which direction that electron, in which orientation that electron is present, and finally the spin quantum number will give the clockwise or anti-clockwise spin of the electron. So when you have all these 4 factors, 4 data together, then only we can be sure of the placement of the electron in an atom, right? So in the next class also we are going to continue about this quantum numbers only. Then we'll actually use it for different elements and find out. So just up to today, what you have to know is there are 4 quantum numbers: principal quantum number, angular momentum quantum number, magnetic quantum number, and spin quantum number. What is their significance towards the electron in an atom? That must be very clear. So yesterday most of you have not written the test. I don't know why, right? Anyway, you take that question paper and try to answer by taking the materials they have already given to you. Next week also you will write the test in the same question paper. Same question paper you have to write the test, because those questions are very important. One, you must know that. Okay, take care. God bless you.